Over the last few months then, I've been trying to acquire a new surface grinder here for my workshop. But trying to find such a surface grinder that's going to fit the size and requirements that I need has provided very difficult. Eventually, after much searching, I managed to find this old Herbert Junior surface grinder from the 1930s. So in today's video, we're going to be making this thing whole again and getting it working. This is the Herbert Junior project. So as great as this thing is, there's a few things that it's lacking. One being most obvious, a motor. So we've got no power. And also there's a few little other issues with the table being really stiff to turn backwards and forwards. And also there seems to be quite a lot of movement on the table, which is probably going to affect the parts. So we need to get all those addressed before we can start using this machine. To start this project off then, I'm going to begin with focusing on the table, as we've got a couple of faults there, and to put my mind at ease, I just want to get those things sorted. So beginning by taking off the mag chuck, I can then start to strip down all the gears and levers that make this thing operate. So being that this machine was from 1930, it goes without saying that everything is sort of old, seized, oh yeah, and imperial. So gonna have to bust out the special spanners for this one, as the majority of my stuff is metric. With the gib screws all now removed, I can begin by sliding the table on the dovetails until I can get it all the way through and manhandle it over to the bench. This is a big old block of cast and it's just me in the workshop. So before I can check if anything's worn or damaged, I just need to give everything a good thorough clean, because there's years and years of grease and metal debris on here, so just need to get all that wiped off. So using a mixture of brake cleaner and GT85, managed to get this thing looking really clean, and surprisingly doesn't look too badly worn. And the surface grinder table was a very similar process of cleaning it down with brake cleaner and GT85. So one thing I have noticed while stripping it down is the sort of gear and pinion mechanism here that drives the table backwards and forwards seems to have a bit of play in it. So luckily for me, this was just a grub screw that had come loose, and tightening that up fixed all this play. With the table and ways all now clean, I can move my focus over to the saddle. So as I found so much grime and debris under the table, I thought it was probably best practice to remove this thing completely and give it a clean down before focusing my attentions on why it's being so stiff to move backwards and forwards. So it turned out it actually took ages to get these saddle strips off, just because some of the bolts were quite awkward to get to. But with them removed, it was a case of just lifting this off and manhandling it again over to the bench. So as you can see, there's so much grime under here, it was unbelievable. But the brake cleaner makes a really good job of getting under there and removing all that stubborn grease, and cleaning it off with some paper towels gets a really nice finish. So before reassembling, I just thought it would be best to oil everything up and make sure everything had a good generous coat. So just using some whey oil there, and then from there I can then put the saddle back on. That is also all being cleaned down, and the movement on that seems really nice. So I know the issue isn't actually in the saddle itself, which makes me think it's something to do with the lead screw mechanism. So the lead screw nut here seems in quite good condition, and I really like the design concept of this being captive in the bar, making it easy to replace in future. So screwing this on, there didn't seem to be any excessive force needed to screw this on, and there wasn't a lot of play, so I really don't think there's anything wrong with the lead screw or nut. It makes me think it's going to be something along the carriage or handwheel side. So oiling up and refitting the handwheel carriage, no real issues there, but something I did notice is the handle seems to be rubbing on the carriage. So I've come up with an idea. I'm going to use a thrust bearing in there. Unfortunately, the thrust bearing that I've got is a little bit slack, So it's going to involve a little bit of machine work here and some bronze to make a spacer ring to go on there. Being bronze, this is machining really easy, and I can take some big heavy cuts to speed up doing this process. So what I'm aiming for is a really snug fit in this thrust bearing, and also a really nice tight fit over the shaft. Oh yeah, and another thing that's really important, this little washer has to be thinner than the thrust bearing, otherwise this is going to be taking the clamping force and not the thrust bearing. So with that knocked up, I can get that inserted into the thrust bearing and get all that reassembled. Lining this up and pushing it down with a socket made it really easy to locate, and then from there I pushed the handle on and gave it a test. And wahey! Look at that, nice free moving action backwards and forwards. Happy that the apron issue is all now resolved. I can now focus on that excessive movement we had at the table at the start of the video. So stripping this down, I've been measuring things as I go, especially this gib strip, and there doesn't seem to be any real excessive wear, so it makes me think I might be able to simply adjust the gib screws up a little bit more, and that will take up the slack. So to do so, I'm going to have to refit everything and tighten them up, and we'll see how we get on. Tightening up these gib screws then is just like any other gib screw adjustment that you might do on the lathe or the mill. The only thing is that there's 5 here instead of maybe 3 that I've seen on my lathe, but the process and idea behind it is exactly the same. So given the fact that I completely removed these, I had to start from scratch and sort of gauge how far in I had to wind these, and from there I carried on going until I got that perfect balance between too tight and too much play. And my final measurement on here was about 0.1 millimeters with the table fully extended, which I think, given the leverage on this, is pretty good. I might be able to get it a bit better, but for now I'm happy. Next thing I need to do then is more of a serviceable item really, and I want to change this grinding wheel because I don't know how long it's been on there and it's looking pretty ropey. With the locking nut and ring now removed, I can take off the grinding wheel and stick a new one on there. But before I replace this, just want to carry out a little ring test. And as you can hear, they're quite dull thuds, which means there may be a crack. Compared to this newer wheel, where you can hear the sort of higher pitched ringing sound. So stupidly, when I bought these wheels, I just checked online what wheel should be on there, and I've ordered a 19mm wheel, which, yeah, I can't get that locking ring now on there, which means I'm going to have to make a new retaining ring to make sure I can use these 19mm grinding wheels. So over to the mill, I'm going to be using a bit of off-cut square bar that I've got left over from the solid tool post build I done many years ago on the Warco WM180, and we're going to turn this down to a circle. So there may be many methods of turning a square down to a circle, but the one that I'm going to choose is to find the centre of this and drill and tap this to accept an M12 tap, and then from there I can stick it on a mandrel, or in my case an M12 bolt, and turn this down in the lathe. So got my M12 thread in there now, and sticking it on a bolt I can begin turning this down until we get a circular shape, which is going to match the circle retaining ring which we've already got on the grinder. With the final OD of this part all now done, I had to move over to the internal diameter, and that was going to be really important to make sure it was a nice fit over the main hub of this grinder. So I'm aiming for 31.75mm. Getting that as close as I can with the drill, I then moved over to the boring bar and began boring that out and checking periodically with a set of snap gauges. And getting pretty close there. We're about 0.3 millimeters away, 0.4 millimeters away. So I've done one final pass and then followed it up with a skim pass to make sure there's no deflection. And yeah, that is a nice fit. Perfect for what we need. So only thing left to do now was to turn this down, as the ring itself is too thick. I need to take off about 0.6 mil. So going to be doing this over a set of facing operations, as I think that's the best way of doing this. So that bar there that you can see on screen is just there in case the part flies off. Assembling this all up now, and that ring fits on lovely, and I can now do up the lock nut to make sure this thing's not going to come flying off when I eventually get round to using this thing. So that's another job ticked off the bucket list of the Junior. Next thing I need to do now is sort out this motor issue. So I've managed to source a spare motor, but it doesn't quite fit on the flange. The flange is a bit too loose and the bolt holes don't line up. So using the power of the 3D printer, I've 3D printed a spacer ring which will fit onto the motor and allow this to fit nicely onto that recessed flange. Ooh, look at that fit. So that now fits in there lovely. But what I need to do is sort out these holes because they don't quite line up. Being a home hobbyist, I like to do things as simple as possible. So transferring some marks from the motor to this plate, I can then line them up with a ruler, and measuring the hole pattern gets me positions of where I need to drill to allow these holes to line up with the motor. So sketchily mounting this into my vise with not a lot of clamping force there. I just went easy with these drilling operations because I need to drill these out to be an M8 through hole, which for me I'm going to drill out to a 9mm just to allow a little bit of wiggle room if I am out. So I'm just going to go up in a set of series of 5mm, 7mm and then finally a 9mm hole to get these things bang on. With that first one done, it was a case of rinse and repeat, lining up the drill with the markings and drill these out. With all these holes now drilled, it was time to test out the theory of my marking skills and see if all the bolts lined up. And 3 out of 4 is the fourth one. 4 out of 4. All of them line up. So I think now it's time to stick this back on and see how everything else lines up. So fitting a new V-belt because the old one was really worn and knackered meant that I had something to mount the motor pulley to. So putting this in position and oh dear, these cap-headed bolts are just catching. Quickly jumping back over to the mill then, I attached some countersunk screws in there and tried again. And second time lucky, boom, fits perfectly. So just getting one nut on there for now to stop the motor falling off, then allows me to adjust all the belt tension up. So tightening it into the top position gives the belt the most amount of slack, which allows me to get this onto both pulleys, top and bottom. And then from there I can loosen that nut off again, drop the motor and tension that belt. And to be honest, the weight of the motor itself puts the majority of the tension on there. And with that being done, the motor is now on there and ready to be powered up, which we'll be covering in the next video, where we wire up the VFD, get all the wiring sorted and power this thing up for the first time and make our first set of sparks. So thanks for watching guys, hope you enjoyed this. If you did, please consider subscribing to the channel and give this video a thumbs up. But for now, see you in the next one.